Question: Benzene and toluene form ideal solution over the entire range of composition. The vapor pressure of pure benzene and toluene at 300 Kelvin are 50.71 mm of mercury and 32.06 mm of mercury respectively. Calculate the mole fraction of benzene in vapor phase if 80 gram of benzene is mixed with 100 gram of toluene. Given vapor pressure of pure benzene, let it be P naught B, is equal to 50.71 millimeter of mercury. Then vapor pressure of pure toluene is equal to 32.06 millimeter of mercury. Weight of benzene, let it be WB, is equal to 80 gram and weight of toluene is equal to 100 gram. As can be seen from the vapor pressure values of pure benzene and pure toluene, vapor pressure of pure benzene is greater than vapor pressure of toluene. So more volatile component is the benzene. Now molecular weight of benzene, molecular formula of benzene is C6H6. So molecular weight of benzene will be, now atomic weight of carbon is 12, atomic weight of hydrogen is 1. So molecular weight of benzene is number of atoms of carbon, that is 6, multiplied by atomic weight of carbon, plus number of atoms of hydrogen, that is 6, multiplied by atomic weight of hydrogen, that is 1. So this is 72 plus 6 is equal to 78 gram per mole. So this is the molecular weight of benzene, let it be Mb. Molecular weight of toluene, molecular formula of toluene is, this is the structure of toluene. So molecular formula of toluene will be, there are total 7 carbons, so C7H8, 8 hydrogens. So molecular weight of toluene will be equal to number of atoms of carbon, that is 7, into atomic weight of carbon, that is 12, plus number of atoms of hydrogen, that is 8, multiplied by atomic weight of hydrogen, that is 1. This is equal to 92 gram per mole. Now let Y be the mole fraction of benzene in vapor phase. Yb is equal to partial pressure of benzene divided by total pressure of the solution, and Yt, which is the mole fraction of toluene in vapor phase, will be equal to partial pressure of toluene divided by total vapor pressure. For total vapor pressure, you need to find out the mole fraction of benzene and toluene in the solution, and for that moles of benzene, which is equal to weight of benzene divided by molecular weight of benzene. Molecular weight of benzene is 78. So 80 divided by 78. 80 is the weight of benzene, 78 is the molecular weight of benzene. This is equal to 1.026. And moles of toluene is equal to weight of toluene, that is 100 gram, divided by molecular weight of toluene, that is 92, and this is equal to 1.087. Now total moles, total number of moles will be moles of benzene, that is 1.026, plus moles of toluene, that is 1.087, and this is equal to 2.113. This is the total number of moles. Mole fraction of benzene is equal to moles of benzene, that is 1.026, divided by total number of moles, that is 2.113, is equal to 0.49. And mole fraction of toluene will be equal to, now mole fraction of toluene can directly be obtained from the formula. Mole fraction of benzene plus mole fraction of toluene is equal to 1. Therefore mole fraction of toluene will be equal to 1 minus mole fraction of benzene, and this is equal to 0.51. Now for the total pressure is equal to, total pressure of the solution will be equal to P naught, that is vapor pressure of pure toluene, plus vapor pressure of pure benzene minus vapor pressure of pure toluene multiplied by mole fraction of benzene. Putting the values, this is equal to 32.06 plus 50.71 minus 32.06 multiplied by 0.49. Solving total pressure is equal to 41.2 millimeter of mercury. Now partial pressure of benzene will be equal to pressure of pure benzene multiplied by mole fraction of benzene. This is equal to 50.71 multiplied by 0.49, which is equal to 24.85 millimeter of mercury. Similarly, partial pressure of toluene will be equal to pressure of pure toluene multiplied by mole fraction of toluene, and this is equal to 32.06 multiplied by 0.51. So partial pressure of toluene is equal to 16.35 millimeter of mercury. From these values, mole fraction of benzene in the vapor phase is equal to partial pressure of benzene, that is 24.85, divided by total pressure. Total pressure is 41.2, and this is equal to 0.603, which is approximately equal to 0.6, and mole fraction of benzene plus mole fraction of toluene is equal to 1. So mole fraction of toluene in the vapor phase is 1 minus mole fraction of benzene in the vapor phase, which is equal to 0.4. Mole fraction of toluene in the vapor phase can also be obtained by applying the formula partial pressure of toluene divided by total pressure, and this value is approximately equal to 0.4. Point to be noted, mole fraction of benzene in the vapor phase is greater than mole fraction of toluene in the vapor phase. Reason being, benzene is the more volatile component. And in the solution phase, if you compare the mole fraction of benzene and toluene, mole fraction of benzene in the solution phase is 0.49 and mole fraction of toluene in the solution phase is 0.51. So in the solution phase, mole fraction of toluene is greater than mole fraction of benzene because benzene is more volatile, so most of the benzene goes into the vapor state. So mole fraction of benzene in the solution is less than the mole fraction of toluene in solution.